We try to find a formula for the derivative of a function which is expressed as a product of two functions. So say r of x is given as a product of two functions, f of x and g of x. So by definition, r prime of x is the limit as h approaches 0 of this fraction where the denominator is h and the numerator is r of x plus h minus r of x. So let's plug in r of x plus h. R of x plus h is obtained by replacing the x's by x plus h's. So it would be f of x plus h, g of x plus h. This is r of x plus h. Minus r of x is given to us as f of x, g of x divided by h. Now notice the numerator I can add and subtract something like, so let me rewrite my numerator. It's f of x plus h, g of x plus h, and I'm trying to get, so let me add f of x plus h and g of x. So this is the term that I added. So I'm going to subtract that. So minus f of x plus h, g of x. And then finally, I have this minus f of x, g of x. So that has gone a little bit longer. But now what we want to do is we want to pair the first and the third term. So let's rewrite the numerator. Limit h approaches 0 and I have f of x plus h, g of x plus h minus f of x plus h, g of x. So let's put these two together, and then the second and the fourth term, we want to write them together. F of x plus h, g of x minus f of x, g of x divided by h. So this looks like I can factor out f of x plus h in the first pair. So I get f of x plus h, and then I have g of x plus h minus g of x. And in the second pair, I can factor out g of x, and then I have f of x plus h minus f of x all over h. So now I can rewrite this as limit h approaches 0, f of x plus h. I can separate this into two fractions times g of x plus h minus g of x divided by h plus, so limit of a sum is sum of limits. So I can write limit h approaches 0, and then it's going to be g of x times f of x plus h minus f of x divided by h. So that's the last line. And notice this quantity with limit h approaching 0 is the derivative of g, and this quantity with limit h approaching 0 is f prime x, the derivative of f. And if I take the limit h approaches 0 of f of x plus h, I just get f of x. So I can write this as limit f of h approaches 0 f of x plus h times this limit h approaching 0 of that limit plus limit h approaches 0. Actually, we can pull the g of x out. So finally, what happens is you get f of x g prime x plus g of x f prime x. Now notice r of x was a product of two functions, f of x, g of x. And then r prime x turned out to be this. And just keeping up with the tradition to write f first and then g. So let me rewrite the above expression, which was for r of x. So let me write down f of x, g prime x, plus f prime x, g of x. So what this is saying is, when you differentiate a product of two functions, so first thing, if you differentiate product of two functions, it's not going to be the product of derivatives. It's not going to be f prime x, g prime x. What you get is two terms. In one of the terms, you differentiate, you fix f and differentiate g. In the other terms, the roles are reversed. The one that got fixed now gets differentiated, and the one that got fixed will get differentiated now. So let's look at an example. So example 1, say I have f of x equals x square sine x. So this is a product of two functions. So if I want to find the derivative, then I can fix one. So let me fix, or let me differentiate x square. I get 2x, and then I fix sine x. Plus, now I will fix x square and differentiate